drag.
Hello everyone and welcome back to episode 3 of the Sciencia cast. Today we're doing a physics topic, drag or air resistance. So, today with me I have Charles and Adam once again, and we will be looking at the wonderful types of drag and how it happens.
Not to be confused with the other kind of drag.
Yeah, exactly. So as we all know, F1 is happening now, so that's amazing. I'm happy about that. But aerodynamics plays a massive importance in drag, and drag is one of the main parts of the sports,
Whoa.
I think you know that.
I have no idea. I don't watch car racing.
Fair enough.
I'm just kind of here.
So, well, I'm looking at the Wikipedia article right now, and it's a bunch of letters, lines, brackets, and square roots.
Pretty pompous.
So there you go. So
is that the entire lesson done? There's a bunch of square roots.
Square roots. So depending on how small and thin the sort of thrusting point into the air is, the less drag you normally have. Unless you just put a needle and then just a brick, I don't think that'll be the most aerodynamic thing. But if you take the needle and then make it into a cone, then it's more air resistant. Less air resistance, less drag, faster. And now we have a thing called dirty air, which is when you have a horrible looking back end that makes the air all horrible, like a vortex behind the car or vehicle or whatever, or anything. And streamlining is insane, because say if you have a car, yeah, and that's driving very fast, the dirty air will have, there's a bit behind, in between the car and the dirty air, which has a lot less sort of friction and air flying at it. And you can be right behind that car and you will gain more speed and you will use less liters of petrol per kilometer, because there's less air resistance and less drag on your car. And it's very effective with supercars. So there you go.
Very nice.
What else do we have? Air resistance with knives. I know Mr. Alan Animates can tell you about how knives have affected his thing if he was on the podcast. But yes I know, funny Soviet man, he can tell me all about guns and aerodynamics, can't you?
Hello?
Yes.
I don't know qualifiers in this department.
Me neither.
Oh. Well.
Anyway.
Bullets are shaped, shape so it moves faster. There we go.
And did you know how would height in the atmosphere affect it?
Well, if there's less air, then it should move faster, I think. That's how planes work as well.
Clever man. Clever man.
Don't fact check me.
That's why things go so fast in space, because there's no air for it to collide with. It's all friction. It's literally all friction. That's basically just drag. Aerodynamics, because you can use plane. There's lots of interesting graphs I would show you if I could, but I do not know anything about drag. But yeah, to summarize everything, because this is a very confusing topic, because none of us are qualified physicists.
Yeah.
Drag.
Only we had Sam, yeah. He's very good at science.
I'm good at science.
Sam's in the lowest set than me in science.
You have sets of science.
I do have sets of science, yeah.
Good. Good to know.
I'm in top set. So I'm smart.
Well, anyway, to summarize drag is air resistance affecting on an object. It's a force acting opposite to the relative motion of any object moving on its respective speed and distance. The sharper your object and the more aerodynamic it is, the less drag it has, the faster it can go, Dirty air makes you slow. Get right up to something's bottom and then you go fast. That was the Sciencia podcast. Thank you for watching. I've been Ben. Charlie's.
I've been myself.
Yeah, you do.
Okay. I've been Charlie.
And Adam's been cooking. Thank you very much for watching, and we'll see you in the next one.
Yep.
Bye-bye.